All right. The first fundamental theorem of calculus states that differentiation and integration are inverses. So the integral from a to b of the function f of x is equal to the antiderivative of f valued at a minus the antiderivative of f valued at b. And so if we are given the function x squared plus 7, and we were asked to find the antiderivative or the integral from 0 to 2, what we do is we first find the antiderivative, which is 3x cubed, 1/3 x cubed plus 7, and we evaluate that from 0 to 2, 7x. And to evaluate that at 2, we do 1/3 2 cubed plus 7 times 2 for our first function. Then for our second, we do 1/3 0 cubed plus 7 times 0. That's our second. So we evaluate what both these are. This is equal to 8/3 plus 14, and that is equal to about 0, so minus 0. And then, so we have 8/3 plus 14, which turns into 50/3. And that is the area under x squared plus 7 from 0 to 2. Now, if we are given the function just, let's say, x plus 1, and we're asked to find the integral from 0 to 4, well, we do 1/2 x squared plus x, and we evaluate that from 0 to 4. And when evaluated at 0, it's going to equal 0. When evaluated at 4, it'd be 1/2 4 squared plus 4, 16, 8 plus 4, which equals 12. So the area is equal to 12. Now we can see that if we were to draw this function, it would look something like this, where it'd be a line. It would start 1 up, it would be 4 wide, and it would be, well, if we plug in that, it would be 5 tall. This is the general shape of the graph. This height would be 4, this height would be 1, and both these bases would be 4. And so this would be 4 times 4, right? 1/2, 4 times the area of this triangle would be 1/2 4 times 4, which would be 8. And this would be 4 times 1, which would be 4. That's going to equal 12, proving that this gives you the area under the curve for a function.